To illustrate further complex numbers, let's introduce the Argand diagram, or also known as the complex plane. Now, our complex numbers can be considered as a point on the said complex plane or Argand diagram. That means if we have here, let's say, x plus yi being our given complex number, x here, of course, corresponds to the real part of our complex number. This corresponds as well as the horizontal axis on the Argand plane. Our y, the imaginary coefficient of our complex number, will correspond into our vertical axis. That would mean our horizontal axis is the real axis and the imaginary axis would be our vertical axis. So basically, it's just the same as plotting a point on the Cartesian plane, but this time our point is a resulting point of our complex numbers. So for our Argand diagram here, let us try to illustrate that these three different complex numbers in our Argand diagram, considering that each grid here is per 1. That would mean for our z sub 1, we can locate z sub 1 somewhere here. Let me use another color. Our z sub 1 is at negative 4. Okay, z sub 1 is negative 4 plus 3i. This would be our x, and this would be our y here. So where can we find our z sub 1? Similar to our Cartesian plane, our Argand plane or our Argand diagram also uses quadrants. Quadrant 1, 2, 3, and 4 in the same order. So since x is negative and our y is positive, we can see z sub 1 on our Argand diagram on the second quadrant. Specifically, it can be seen at negative 4, okay, and positive 3. This is where we could find our z sub 1. Okay? Or basically, this is where we have our negative 4 plus 3i, our z sub 1. Similarly, for our z sub 2, where 2 and 5 are both positive numbers, so we can actually locate that on the first quadrant. Meaning, you have here 1 and 2, 1, 2, 3, 4, 5. This here is where we could locate 2 plus 5i, and that's our z sub 2. And for the last one, for our z sub 3, where we have here negative 8, and of course we know that to have negative 1, both numbers are negative, it would be on the third quadrant. So negative 8, that's negative 4, 5, 6, 7, 8, negative 1. Here, this is our negative 8. Sorry, that's 8. That should be 8 minus I. So we can still locate the points on our Argand diagram or a complex plane, and of course they could stand as point. So this could also be written as 2 and 5. This could also be negative 4 and 3, and this would be negative 8 and negative 1. But basically, they stand for complex numbers. Now, if we are going to draw a line from that complex point to our origin, we can still find a certain line here, and hence there would be a corresponding distance between the complex points as well. So the distance will still have the same formula, which will be introduced later in the next video. So if you have a complex number, just by one look at it, you can automatically say which quadrant it would belong on our complex plane or Argand diagram, and at the same time try to predict its further behavior. Thank you very much for watching.